Welcome everyone to my talk. First of all, I want to thank the EER for their invitation to present this work and SNF for the authorization for publication. This talk is the third of the series after the presentation of my colleague Yann Neuwerf and Flavien Galtier. On my side, I will talk about the sustainable oil production in Colombia using polymer floating. So here is the agenda of my presentation. I will start with a focus on the oil demand, on the projection of the oil demand by 2045. Then I will present you the technology of polymer floating and what are the sustainable benefits of polymer floating to increase oil production, and how this can be applied to Colombian oil fields. Finally, I will conclude my talk with the main takeaways. So on this slide, which has already been presented by my colleague Yann Neuwerf, it is a projection of the oil demand by 2045 according to the OPEC, which has been published in the World Oil Outlook 2045. So what you can see is that between those two figures, you can see the evolution of the energy mix between 2020 and 2045. You can see that the oil will still be the main source of energy by 2045, with about 28% of the market share. What you can see also is between 2020 and 2045, you have, first of all, an increase of the global energy demand by 28%, and in particular, an increase of the oil demand by about 20%. Now, if you look also to the evolution of the demand for the key thermoplastic in the industry between up to 2050, what you can see is you have a constant increase, and an increase which should be about 43% between 2020 and 2045. So accordingly, you will also have an increase of the demand in oil for this application. So if we summarize, we should experience an increase of the oil demand by 20% because of the increase of the energy demand. These projections are even stronger according to the IEO, which report an increase of the energy demand by 40% in 2045 and an increase of the oil demand by 36%. We should also have an increase of the demand of thermoplastic with more requirements and with more demand on oil to satisfy this application. So now the main challenge are how do we satisfy the oil demand while the oil production coming from mature assets is declining. And also how do we combine this challenge with the reduction of carbon intensity of the oil to meet the net zero target. If we look at what is the position of the sector in the oil and gas, so we can see that we have a fall of the investment between 2019 to 2021 by 35%, decreasing from $525 billion to $341 billion. According to Joseph Magnogli, the Secretary General of the IEF, we have to get back to the level of investment of 2019 for several years, at least until 2030, to be able to restore the market balance. According to John S., the CEO of S Group, oil and gas is part of this solution to be able to satisfy the global energy demand and not the problem. In particular, it insists on the fact that we are able to decrease the carbon footprint of the oil by 10% in 10 years, and that the real takeaway is that the energy transition will take a long time, cost a lot of money, and will need technologies that does not exist at the moment. So to be able to try to bring affordable energy on the market and satisfy the oil demand in a world where we have less investment, less discovery, and so on, one of the best way to do it is to implement an enhanced oil recovery method to be able to boost the oil production from existing assets while reducing their carbon footprint. So when you have a look to the different enhanced oil recovery method available in the market, you can see that one of the most easy one to apply is polymer floating. So polymer floating, it's a proven technology with more than 300 applications worldwide. So it consists of adding polymer to the water we inject in the reservoir to be able to better sweep the reservoir and increase the oil production. The addition of polymer improves the mobility control between the water and the oil and limits and prevents the fingering of the water through the oil. Also, we have developed recently new facilities which are available in sea freight containers, which can be used to progressively deploy the technology on the field according to the development phase of the project. This equipment can be directly plugged into the existing water network on the field, and you can easily relocate those units as required according to the development you want to apply on the field. Polymer floating is also a robust technology suitable for a wide range of reservoir conditions in terms of reservoir temperature, water salinity, but also permeability. You have product available in powder form for onshore or offshore application, but also in liquid form, mainly for offshore application where we have poor sea conditions. Polymer floating is also cost efficient. It helps to maximize the oil recovery. It has been adopted massively in China since the 90s. Then about 12 years ago, it has been chosen by India to be able to sustain the oil production and satisfy their oil demand. And you have a nice example in Rajasthan, where you can find the largest polymer float project in the world. And recently in Argentina, you have publication from YPF reported record of production thanks to polymer floating, especially in Manantiales. Polymer floating is also has a cost which is also limited between $3 to $6 per incremental barrel, which allows to decrease the cost of production of the oil for a given operator, and it is way cheaper than exploration and production activities. Polymer floating also accelerates the oil recovery. So these figures have already been shared by my colleague Flavien Galtier, and what you can see mainly on this figure is on top of having more oil being produced with polymer, you are also able to accelerate this oil production, since what you had produced before with water injection is now produced with polymer floating 6 years earlier in this case. What I want to show you in this presentation is more the sustainable benefits of polymer floating from an environmental point of view. So what I want to show you is that polymer floating is able to reduce the CO2 emission by 60% per barrel of oil produced. It's also able to reduce the water use by 70 to 80%. And polymer floating finally is carbon neutral from a chemical point of view. To come back on the reduction of the water use, here I come back to the example from Chevron, but this time not on the graph, but on the table you can find in this presentation. And at the bottom of the table, what is very interesting is that you can see that implementing polymer floating, you are able to reduce the water handling by 88.7%, which is considerable. So today, if you consider that you have about 60% of the reservoir which are producing water, which are produced under water injection, quickly when you inject water in a reservoir, you have a raise of the water cut, and when this water cut raises above 80 to 90%, you have a massive increase of the XRG investment and of the CO2 emissions. So if you are able with polymer floating to reduce this water cut, you are able to reduce the CO2 emissions. So here it is an example of that. So let's consider that you have water flooding operation producing at a water cut of 90%, and you implement polymer floating and you are able to reduce the water cut to 70%. When you inject 10 barrels of water with water floating, with a given amount of energy and consumption of oilfield chemicals, you will produce 9 barrels of water and 1 barrel of oil. With polymer floating, for the same 10 barrels of water and approximately the same level of energy consumed and same consumption of oilfield chemicals, if your water cut has decreased to 70%, you will now produce 7 barrels of water and 3 barrels of oil, which represent an increase of a factor of 3 of the oil production. Now, if you go back and look at the production of only 1 barrel of water, with of oil, pardon. Sorry. So if you are injecting water, so you will need to inject 10 barrels of water to produce 1 barrel of oil, while with polymer floating, you will need only to inject 3.3 barrels of water to produce your barrel of oil. So this represents a 67% reduction in water use at the injection. On the production side, with water injection, you will have to produce 9 barrels of water to produce 1 barrel of oil, while with polymer floating, you will produce only 2.3 barrels of water. So this represents 74% of water production thanks to the implementation of polymer floating. As mentioned at the beginning, if you have the same consumption of energy and oilfield chemicals in these two scenarios, you will have a reduction of consumption of energy and oilfield chemicals per barrel of oil produced, which is proportional to the increase of oil production, in this case by a factor of 3. So let's consider the field case of the Lloydminster polymer float pilot in Canada. So in this pilot, polymer floating has been applied as a tertiary recovery method. So during the primary phase, you have a steady oil production, and after 55 months, you have an increase of the oil production because of the addition of extra producers. But you see that you have quickly a decline of the oil production. During this period, the CO2 emissions are limited to about 17 kilograms of CO2 per barrel. Then we switch to water flooding as a secondary recovery method, and we observe that after switching to water injection, we have an increase of the oil production for 10 months, followed by a production decline. Okay. During this period, you can see that you have a sharp increase of the CO2 emission because of the injection of water and the production of water increase of water cut. And you can see that you can reach value up to 100 kilograms of CO2 per barrel of oil produced. Then when we switch to polymer floating, we observe an increase of the oil production by almost a factor of 3.5 and a reversal of the CO2 emission curves from 90 kilograms of CO2 per barrel down to about 40 kilograms of CO2 per barrel. And what you can see is you have a sustained oil production with a very little decline, and also a sustained level of CO2 emissions much lower than what you would have obtained if you have continued to inject water. Now, if we have a look to what happened in Colombia, so in Colombia, what we can see is that we had several EWR realization which has been implemented. So you can have a colloid dispersion gel in the Negreta South, polymer floating in Palogrande, in Chichimene, in Yarigui-Cantagallo, or in Casabe, and even alkali surfactant polymer pilot in San Francisco. So on the next slide, I will focus only on Palogrande and Yarigui-Cantagallo to show you what was the impact on the CO2 emission and water use implementing polymer floating. So here what you can see is according to the publication related to these two applications. So in Yarigui-Cantagallo, we have observed CO2 emissions reduction by 35 to 50% and water handling reduction by 40%. Also, the authors report that the cost of polymer floating in this case was in the range of $4.6 to $6 per incremental barrel, which is quite in line with what I've shown you before, which was about $3 to $6 per incremental barrel. In Palogrande, the CO2 emission reduction is between 50 to 60%, while the water handling reduction is about 60%. So with this cost of polymer floating estimated between $4 to $6 per incremental barrel, you see that polymer floating is a very affordable method to increase oil recovery, and which is cost efficient even if you were in a period with a low oil price, which is not the case at the moment. So here are the main conclusions of my talk. So what we have shown is that polymer floating is a proven technology to increase and accelerate oil recovery in a wide range of field conditions. Polymer floating also presents several environmental benefits. So it allows to reduce the CO2 emission by 60% in average per barrel of oil produced. It also allows to reduce the water use by 70 to 80%. And also, polymer floating was successfully applied at a pilot scale in Colombia in several fields. And it allowed to achieve in Colombia a similar level of reduction of CO2 emissions and water use than what we observe globally. Polymer floating is also a cost-efficient technique that contributes in solving the dilemma of increasing oil production to satisfy the oil demand while decreasing the environmental footprint of the oil production. So with that, I want to thank you, and I'm at your disposition if you have any question. Thank you.